Hello, this is OCR Further Statistics. We're in Non-parametric Tests 1 and the fourth and final video on using normal approximations for large samples. Sometimes it's a good idea to stop and work some things out for yourself. Whenever you see this symbol, pause the video and try to answer the question before continuing to watch. You'll have noticed that the tables only go up to a sample size of 20. You can get tables which cover larger samples, or in fact work out the probabilities yourself. The distribution is not complicated, and investigating it is an interesting exercise. But it's not really necessary, because for larger n, both W plus and W minus can be approximated by a normal distribution. This information is provided for you in the exam, so you just have to remember to use it. The only problem is that W plus and W minus are integers, so they are discrete distributions, and the normal distribution is continuous. You've come across the need for a continuity correction before, when using the normal distribution to approximate the binomial. You'll see how this works in the example. OK, a school has been using a standard reading test for years and knows that the median score for its 7-year-olds is 50, with a roughly symmetrical distribution. They have introduced a new reading scheme and want to test its effectiveness. The current cohort appear typical of previous cohorts. The whole year group is tested and the following results obtained. Test at the 5% level whether the new reading scheme has improved or worsened outcomes. OK, so the key information in this question is that the original median is 50, the significance level is 5%, and it's going to be a two-tail test, as they don't know if the new scheme will be better or worse than the old one. So, our null hypothesis is that the median is 50, and our alternative hypothesis is that the median is not 50. Pause the video while you use a spreadsheet to work out W plus and W minus. OK, so for a sample of size 34, the sum of the ranks, which is W plus added to W minus, is 595. Here's the table. I ordered it by absolute difference after I'd highlighted the negative differences. It's a bit small, but if you didn't get these values for W plus and W minus, then pause the video and find your error. W minus is smaller, so T is equal to W minus, which is 219. Then, using the formula from the formula book for the mean and variance of the approximating normal distribution, we get a mean of 297.5 and a variance of 3,421.25. Don't forget that your calculator wants the standard deviation, but it will accept an inputted square root, so no need to work this out at this stage. So we want the probability that T is less than or equal to 219. That means we have to count the 219 interval, so we go up to 219.5. Plugging that all into the calculator, we get a probability of 0.09, which is greater than 0.025, remembering that we are doing a two-tail test. So, we don't reject the null hypothesis. There is insufficient evidence to suggest that the median reading score has changed. That's the end of this video, and the end of this first section on non-parametric tests. If you haven't already done so, try to get some real data to try this out on.